Okay, good evening. Welcome to
SuperMath number 67a.
SuperMath67a. We're going to talk about the medians of the triangle today. And this I think, what we're going to talk about is one of the coolest proofs in elementary geometry. So, and since we're starting a new section about the medians, and it turns out it's the first example, I thought we would just go through it in the movie. You read through the example this morning, so you're not seeing it totally for the first time, but we've not really talked about medians before. What are medians?
So they're a line segment coming off from, like, we'll say this C, and hitting the midpoint of line AB. Okay,
they're the line segments that go from the vertex to the middle of the opposite side. So it divides the opposite side in half. And I'm going to follow the book's convention here, and just for now we're going to assume that they intersect in a single point. Okay?
And we'll prove that later.
We'll prove that at a later date. It's actually not that hard. In fact, you and I have talked about Chiva's theorem before, just as an introductory geometry theorem. Chiva's theorem says when you take all the ratios and multiply them together, so this to this, times that to that, times that to that, when you get 1, that means the lines all intersect in a point. That's certainly true with the medians because the ratios are all 1. So 1 times 1 times 1, but probably that's how we're going to prove it later, actually. But today we're going to prove something different. A, B, C, D, E, F. We're going to prove that these 6 triangles that you get from drawing the medians all have the same area. And this is what is one of the most incredible proofs, I think, in elementary geometry. So I'm going to call the area of this triangle, what am I up to, G? Area of this triangle, BGD, is X. And the first thing we're going to show is the area of this triangle, CGD, is also X. Why is that true?
Well, these triangles have the same height. The CD, and they have the same base. The CD is DB.
Okay.
And the height, they share the height.
Okay, draw in the height for me here of this triangle. Okay, it's not necessarily GD, because that's not necessarily perpendicular.
Yeah, that would be for an equilateral triangle.
Well, there might be some other cases where it's perpendicular, but it's not necessarily perpendicular, but it comes down from G and hits this line CB. And this is the height, and their bases are the same because that's the median. Okay, divides the opposite side in half. So this triangle has area X. What about this triangle here? What's its area going to be?
It's going to be Y by the same procedure.
Okay.
They have the same base and they share the same height.
Each of these two triangles, CGE and CEA, have the same base because this is a median, BE, and they have the same height because we can draw that perpendicular down again. Okay. So what's this area?
That's Y.
Okay. And what about this area?
It'll be Z.
BZ. Okay. So we made some interesting progress. We found that there are 6 triangles. 2 have the same area. These 2 have the same area. Those 2 have the same area. Now, we're going to move on to part B.